MacBook on the table. Who's so dusty you always fail? We have an A2141. I already cleaned this out a little bit, and you might be thinking, wow, this probably has a bad SSD controller, which is immediately what I thought, because it's a 16-inch 2019 MacBook Pro, but it seems to have something else going on, which is maybe a little bit worth showing. So let's look at it. Let's see what all of our ports do. We'll start here. Actually, we'll switch to overhead cam view. Move some things out of the way. Okay. All right, so we start on this port. 5 volts, pulses up. Blah blah blah. Now it's doing a thing. In fact, here, let's go. Let's look at this. I like the little. We can use our graph feature. Okay. Create new. All right, so this is our top left port. All right, kind of stabilizes it, 0.28. Bottom left port. We see a similar sort of thing, right? Same exact shape, that sort of thing. And if I remember which one was actually bad. All right, this is our bottom right port. This is our upper right port. Two of these kids are kind of not like the other. Here, let's pause that. I don't know if I can actually scroll through this, right? But we can see basically, the shapes on all the different ones are different. Let's use a thermal imager and see something that I see as kind of more of a dead giveaway. Generally, whatever port's doing different stuff than the other ones is going to be the bad controller. I wouldn't really think that we have like a bad ROM or something like that in this case, but let's look at this. Okay, so I'm just going to plug in over here. Plugging on the left side, and oh, this guy's getting hot. I shouldn't be doing that. Bottom left. Oh, this guy's getting hot. Lower left. Oh, this guy's getting hot. Upper right. You know the drill at this point. Right, so it's our one on this port, I think, which is this guy, which is, I think, what, that's U3100. This is a 2019 16-inch Pro, so these have OTP configuration, so we're going to need to pull this guy off of another A2141, reball it, and put it on here, because if we grabbed this one, or one of these two, or just something from some other MacBook and put it there, well, it wouldn't work, and it would do weird shit with T2 and blah, blah, blah. This device also really commonly is going to have issues with T2 after USB-C related issues. So hopefully it doesn't, but if it does, then we can try to, DFU revive or something like that. I'm going to take out the board, and then we'll get that chip off and kind of have a better look at the back side of the board too, but should be bad U3100, maybe T2 weird shit too. We'll see. Here's your problem. Here's your problem. Look at all that. Ugh. 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 Okay, we're gonna clean this off more, and then we'll start removing shit. All right, just like in surgery, you want to mark the leg you're gonna cut off. Always mark your donor board so you don't accidentally start doing repairs on them, or worse yet, pull something off of your actual patient board kind of flippantly. That's probably good practice, just to always pretend you're not trying to damage other stuff on the device. So we're going to pull this guy. Well, yeah, let's just remove the one from our patient first. So, temperature at, the temperature. The very secret temperature. Get some flux there. And let me get my good tweezers. And let's get this feller off. I'm heating up the ultrasonic cleaner right now because this board was just so dead. You can see it. Well, I cleaned it off with a brush and alcohol after just, you know, dusting it with an air compressor. I'm gonna ultrasonic both ends of this board. It just had so much dust, so even though like it doesn't seem like the SSD controllers are bad, there's no shorts on the SSD lines. I checked that. That was the first thing I checked on this, just because it fails so much. We seem to have a USB controller issue. They'd probably fail in the future if I just left them as is. And this one is primarily for data recovery purposes. I believe this customer already got a new device. But you know, if it can work long too, great. All right, so we got that off. This board's gonna be kind of warm right now, so let's go ahead and just wick this area and prep it for the new chip. Go ahead and set the bad chip kind of off to the side, so I don't, again, you don't want to mix it up with your, good one, especially something like this, right? It's like I need a board every single time to pull a single chip off of, or you would need to order these from like some AliExpress seller who's maybe or maybe not correctly sending you what you need. I believe there's some I forget the seller. There's one at least that's quite reliable, and like if you ordered U3100 for an A2141, they'd actually send you the correct thing, which is nice. Personally, I'd rather just get donor boards and pull them on this guesswork. Okay. All right, so we've got some leaded solder on that. I'll get the larger iron. Some wick. Get off the solder. Okay. It's very important to cut this under the microscope for some reason. Okay. Okay, looks good. So now this area is, well, I got two pieces of wick there. Really want to ever need one for something like this. Let's get magic eraser sponge and some acetone. Nice and clean. Remember, that's ready to put the new chip on in a second. We're going to need to reball one from our donor first. Let's get that off. Okay. Set this aside somewhere. Okay. Grab a stencil, which I think I have right here. Wonderful. Same sort of idea. On the actual pads on the board, you want to get leaded solder on this lead free just to get it out of there. Pencil. I feel like my eyeballs aren't working. Stay. All right. I'm not even in microscope view. Okay, let's go to that. Paper towel, get a little bit of solder paste, try it out. I think once I get this chip on, we're just going to ultrasonic both sides of the board and just clean them really thoroughly so we can be sure there's no like debris under, let's say, the SSD regulators or just the other CD32s or whatever BGA chip on the edge of the board that was incredibly dusty. What we don't want to do is, oh, okay, cool, we got it running 20 volts now, and then some other chip fails that's not, already bad. So, okay, let's do that. Stencil aside, a little bit of flux on there. Right. Looking good. Nice balls. Okay. Putting this on. Okay. Go back to a higher temperature now. That is on. Let it cool down for a little bit. Then we're gonna clean this off, and we'll see if it turns on. Probably will. Might be a DFU mode or something weird because it's a T2 device. We'll see. Okay, so this has gone in the ultrasonic deep fryer, both chicken wing sides. We can see the board's looking a lot cleaner. Also just did the other side as well, as I wanted to make sure there wasn't any shit under other chips on the edge before I run power into it. Let's see what it does. Oh boy, I sure hope it works. Oh boy. Yippee! 20 volts. We're going up in current. So this actually looks like it's not in DFU mode, and it's turning on. Hooray! Okay, let's put this back together and test it more thoroughly. I'm gonna go ahead and cover the SSD regulators with some conformal coating glue, so these don't get killed again. I mean, they weren't dead in this case, but you know they do die a lot. So I'd like to protect it from that issue because that is a much more unfortunate problem. Because these will often fail in a way that kills the storage. I actually have another A2141 mail-in that has an internal board short right here, and I'll need to drill a hole in the board, similar to another video we made, but this one's board short is a bit deeper into the board, which is going to suck. That one might just be a no-go, unfortunately, but we'll try. I'm stubborn, and I'll do stupid things like work on things that are almost certainly a lost cause for several hours. But that's why people send us stuff. Maybe not. Oh well. Okay. Alright, we'll do this one, then we'll do the other one, and then we'll close this back up. I still think dust probably did this in, but looking at this guy's ports too, they're also all kind of chewed up and mangled. We can see these ones have pins bridging to each other. So similarly, the cable he has at home is also bad. Probably just going to make them buy a new cable. $10. I think I'll just replace both USB-C ports because this is also like a $2 or $3 part, and why risk it? Swap those out. Yippee. Okay. This one's data recovery, so I think I'm just going to go ahead and back this up. Hoist. That's not too much to talk about here. I mean, let's look at right. What do we have? This bad boy. If one of these fails on the board, the whole thing is not going to turn on. In this case, maybe the mangled port is what did this in, because it did have just full-on shorted pins. This also was like incredibly dusty. One of the more dusty A2141s I've seen. So after getting this chip replaced, pulling one at the same location, another board, reballing it, getting it on there, before we even ran power through it again, we just ultrasonicked the board on both sides. So here and here, gave those a full dunk, cleaned them, and then covered the SSD regulators with underfill so these don't also just fail from dust and kill the storage. Again, this guy already's got a new machine, so I'm just going to make a backup, and then we can get that stuff moved on to their new device, essentially. The graphing feature on this that can show you, you know, visually what's different. Really for this, like, you know, it's the one that's pulsing here. That's, or actually rather, I'm sorry, it was this guy that was bad. So we could see this one tries to initialize, kind of similar. It has that same sort of curve there. And this one's the most dissimilar from the other ones. Typically what you would see is kind of 3 behaving almost identically and 1 bad. Maybe the mangled port on that one is kind of more what gave us that. And even the port on that other side, it seems like this person just kind of used the right side chargers more because they were much more scraped than the left. But we got new USB-C ports in there too on both sides, just so we don't have any pins touching each other that shouldn't be. I have this little USB-C meter linked in the description for every video if you want a fancy one like this. Simple ones are fine too. I really like, this isn't something I use very often. I'm just going to kind of look at the current and I can just see, oh, okay, that's different, you know, etc. It's nice to have as a visual example, I think, especially if you're, you know, trying to maybe teach someone else or show them, having this sort of visual cues for what's actually going on. It makes a lot more sense because you can literally just compare the shape rather than like trying to feel for how the current's jumping around or something like that. Hopefully this helps someone fix their MacBook somewhere, and we'll see you in the next MacBook video that I feel like recording and editing. Bye bye.